calculate the length of AC, the distance between the observer at A and the foot of the building. So let's go ahead and take a look and see what is happening. So in the diagram, C is the foot of a vertical building. So yes, C, right? The foot of the vertical building. And D is the top of the same building. And there we go, our haunted house. And then the height of the building, CD, is 16 meters. We can clearly see it is shown here, 16 meters. Let me change that a bit. So we have 16 meters. Still not really visible. Maybe I should use the red. Let me give it a try. Or let me just write it on this side. So that is 16 meters. And then the two observers are standing 19 meters apart at points A and B. So we have an observer at A and another one at B. They are 19 meters apart. A and B are where A, B, and C lie on the same horizontal plane. Okay, a painter, right, is working at point E, somewhere here, right? And then on the building, the angle of elevation of D from A is 46.85. We can clearly see that on our sketch. And then DEB is 122, here it is, and BCA is 105.61. So let's go. We're looking for the length of AC. We can see here that we have a right angle, the triangle, right? We are looking for the length of AC. The first thing that I think about is trig ratios, because I have a right angle, the triangle. So I have the opposite, which is 16 meters, right? Opposite to the angle A here. And I'm looking for the adjacent. So which trig ratio do I use in this case? Well, tan of theta is equals to y over x. Tan of theta gives us the gradient. So it is y over x. In this case, we're going to have tan of 46.85 being equals to 16 over AC. So AC is equals to 16 over tan of 46.85. So now I just need to put that in my calculator. 16 over 46.85. And then that is 14.9987. I think I can round that off to 2 decimal places and write it as 15 meters. That is 8.1. What about 8.2? Let's hear the stories. Calculate how far the painter at E is from the top of the building. Okay. So, like I've always said, it's better to start from a triangle with a lot of information and move towards the triangle without. So let's see how that plays out. In this question. We know that AC is 15, right? So we have 15. We have 16 in place of CD. So and then AB is said to be 19. AB is said to be 19. And then we have the angle C. We have the angle C. So how can we move from AC to finding C? Well, E, right? Or at least CE. Because if we have CE, we can just say 16 minus CE. So how can we do that? How can we move in that fashion? Right. So we have the length of AC, which is 15. We have AB, which is 19. And we are given this angle, right? 105.61. If we apply the sine rule on this triangle, we can say angle C over sine of angle C over the opposite side, and then we can say 50, no, not 15, but sine of B over the opposite side, which is AC. And then if we do that, we're going to have the size of angle B. But why do we want the size of angle B? Why do you want the size of angle B? Well, if we have angle B, let's say we do manage to calculate the size of angle B, then we're gonna be able to find the size of this angle here, angle A, right? And then why is it important for us to find the size of angle A? If we find angle A, then we can use the sine rule once more to find the length of BC. Okay, if we have the length of BC, what can we do? Okay, we have BC, and then we have this angle here, right? Because we have that other one which is at the top, and that's a straight line. So we have 122, so the one at the bottom, it should be 180 minus 122, which is 58. So we are going to have BC, we're going to have the angle there at the top. This is 90, so we can also find this angle. I think using trig ratios, we should be able to find CE. Okay, so let's go ahead and put all of that in motion. So we are saying we want to start by finding the size of angle B. Okay, so we're going to say sine of C, angle C, right, divided by AB is equals to sine of B divided by AC. So here we have sine of 105.61 divided by AB, which is 19, being equals to sine of B. So this is what we want to find, divided by AC, which is 15 units, right? So sine of B is equals to, so this is 15. I have 15 multiplied by sine of 105.61 divided by 19. Yes, and then I'm getting sine of B being equals to 0.7604. So B is equals to, let me take sine inverse here. When I do that, I get angle B being equals to 49.4955. So this is the size of angle B. This is the size of angle C. So we should be able to find the size of angle A. So angle A is going to be 180 minus 105.61 minus 49.4955. So allow me to put that in my calculator. 180 minus 105.61 minus 49.4955. I'm getting 24.8945. So 24.8945. So now we will use angle A to find CB, right? So we're gonna say sine of A over CB is equals to sine of, now we have the freedom of choice, C over AB. So CB is going to be equals to sine of A multiplied by AB divided by sine of angle C. So let me put that in my calculator. Sine of A is 24.8955 multiplied by AB is 19 divided by sine of C is 105.61. So CB is equals to 8.3. So this is 8.3 meters. So we have CB, which is 8.3 meters. Let me just erase some of these things. So CB 8.3. So this is 8.3. So I can use trig ratios here. Which trig ratio though? To have the size of angle B. Oh, okay. Not yet. I don't have the size of angle B as of yet. But obviously, I can also use this angle 58 degrees. Yeah. So this 8.3, if I use 58, is going to be my opposite, right? So I'm looking for the adjacent. So tan of 58 is equals to 8.3 divided by CE. So CE is equals to 8.3 divided by tan of 58, 5.1864. So from C to E is 5.1864. So how far is E from D? Well, 16 minus the answer. It is 10.81 meters apart. What is the question? Yeah, it is, how far is it? It is 10.81 meters far from point D.